Hey guys, I wanted to talk to you today about solutions and how things get dissolved and how things like, especially with water, like how does it become a solution? What is a solution? A solution, I'm going to go over a couple of terms. You're going to see these terms, okay? A solution is something that is, everything is, it's mixed in and it's all the same. Like it becomes, it's unified throughout the whole thing. It's called homogeneous. Homo means the same, and whatever, the rest of it means the mixture of it. So if you take, like, for example, let's think of like a slushy. Okay, a slushy is one solid drink, but it's got little bits of liquid and little bits of ice. It's not all mixed in completely. Okay, milk is actually one of those types of things. It's got little fatty blobs mixed with little liquid blobs, and they don't mix completely. They're so small that it kind of, to our eyes, it looks like it's mixed in, but it's not. It's not a solution because it's not completely mixed in. Salt water is a solution. It's, if you stir salt water, the salt goes away and it mixes into the water and it becomes part of the water. It's not just little salt particles mixed in the water. It's part of the entire thing becomes salt water. Okay, so a solution is something that's all mixed in together and it has become one substance. It's no longer two little substances next to each other. Okay, kind of like a soda has like all of the particles, everything's all mixed in, but a slushy has particles of ice and particles of liquid. It's a little bit like that. Okay, so then the next term we're going to talk about is solvent. A solvent is the thing that does the dissolving. So like if I put salt in water, the solvent is the water because it's doing the dissolving. Solute is the thing that gets dissolved. It's the item that gets dissolved. So if I put sugar in water, sugar would be the solute. If I put salt in water, salt is the solute. If I put, I can't think of any other examples, but let's say if I mix something into the air, if I put like say helium, I let helium go into the air, it mixes in and it becomes, that would be the solute, the air would be the solvent. Okay. All right. The other terms we're going to talk about today are polarized and ionic bonds and ion. And I'm going to talk about those. I'm actually going to show you a little video clip while I do so. So bear with me for just a second while I try to get my screen sharing to work. Actually, I can pause this while I do that. Okay, so you should be hearing me again. Let me get my screen shared. Here we go. Okay, so hopefully you can see this screen, and I'll have to double check the video just before I post it. But this is a video about how water dissolves salt. Okay, so first let me just go ahead and get started. There's the person who made it, Canadian Museum. Okay, so first of all, that right there is a water molecule. If you take a look at that, and hopefully you can see my mouse moving and everything. If you take a look at that, this water molecule is H2O, remember H2, and then an O, an oxygen, so hydrogens and an oxygen. And the way this molecule is, the way they bond, the hydrogens bond to the oxygen, and I'm not gonna go into why, it's a more complicated than I can explain at the moment, but what happens is they tend to bond kind of close together on one side, and it leaves this whole part of the atom by itself. So all the hydrogens are kind of closer together. Well, what happens is that actually makes it so that all of the electrons are kind of not distributed evenly, because the electrons are kind of going around here and around this and here and around this and so forth. And so they're not centered correctly. So we end up with the electrons kind of being imbalanced. Like as they're going around the atom, as they're moving around, they tend to be imbalanced because they kind of go like this, they go around and they just kind of, it ends up being imbalanced. So what ends up happening is we get this thing called polarization. Polars, if you think about the North Pole and the South Pole, that's the poles, polar, okay? Opposites on one side and the other. In this case, we have a negative and a positive side, and I don't remember which one's which, but let's just pretend for now that this is the negative side. That would be where the electrons were more, and I don't know, I could be wrong, could be that side. And that would be if that's the case, would be the positive side, and that's where the electrons are not there, but I have a feeling it's probably opposite. Anyway, that'll make the atom itself kind of like a magnet where one side is attracted compared to another side, okay? And it'll explain that a little bit further. So let me go ahead and hit play again. Oh, this is a water molecule. Okay, and that is a chunk of salt. We're looking really, really, really small at this. This is the small scale. Like salt, clearly, this would be just one little cube, and that's even way smaller than our eyes can see. Those are water molecules. They kind of tend to clump together a little bit too, which is kind of why water tends to, if you pour it, you notice it kind of bubbles up a little bit. That's why. I was right. This is where the negatives are, and this is where the positives are. So this, and then salt itself, let me go ahead and explain. So salt itself is actually has a positive and a negative charge. You remember how when we talked about, I'm actually going to pause my screen share for just a minute. Let me just stop that. Okay, so we talked about salt. We talked about ionic bonds and ions. Okay, and sorry, my fingers are dirty. It's just paint, but still. Anyway, so an ionic bond is when you take, if you remember, we talked about atoms. If you take an atom that happens to have an extra electron and it finds an atom that doesn't have an electron, an extra one, it has a hole, this electron will go over here. It makes this guy now has an extra electron, which is an extra negative. So he gets one of these guys, and these are negatives. So he gets an extra negative. Now he's more negative than he was before. So this guy actually ends up with because he got that extra negative from the other guy, he's now extra negative. Oops. That's supposed to be a negative sign. Okay. Over here, this guy lost his negative. He lost it. So he's now actually extra positive because he lost his negative. He gave it away. Okay, so we have a polarization here again. We have one positive and one negative, and these atoms, they kind of attract because one's positive, one's negative, just like magnets. The positive and negative attract. So they kind of stick together, and it's called an ionic bond because this is a positive ion now, and this is a negative ion. An ion is just an atom that does not have the right number of electrons. Okay, so we got negative or positive ions depending on whether they gave one away or took one on. Okay. Ionic bond is because they're now positive and negative, they attract to each other, okay? Remember we talked about it being the me, myself, and I, ionic, selfish bond. It basically, this one steals the other one, okay? So let's read that sentence I wrote on the bottom. I'm gonna have to turn it a little bit. It says electrons, which are negative, oops, turn it so you can see it too. Electrons, which are negatives, goes to the other one. So the electron from here goes to the other one, leaving it with a one less negative. So it's now a positive ion, and the other one, so this one's now a positive because it lost its negative. The other one now has an extra electron or a negative, and so now it's more negative. That's what I just said, but this is just it in written form. Hopefully it's not backwards for you because it looks like backwards on my screen, but if it is, oh well, I said the same thing anyway. Okay, I'm sorry if you didn't get a chance to read it. You can rewind and pause if you want to. But it's exactly what I said, okay? All right, let me go ahead and share my screen again. Okay, let me hit play again. All right, so this is a salt molecule. It's a positive and a negative, and they're stuck together with a whole bunch of them because they're all attracted. Well, the water comes along, remember, it's got a positive and a negative side. The water says, hey, we're positive on that side. Let's take some of the negatives. This one over here, this says, hey, we're negative on that side. Let's take a positive. And so what happens is the water comes along because it's attracted. It will take parts of the salt. It'll rip it apart, basically. Okay, so this one happens to, oh, anyway, it's gone. I can't show you now. But you can see it taking it apart because parts of the water molecule are negative, and where it's negative, it's going to find the positive guys. And where it's positive, it's going to find the negative guys. And it just slowly takes it apart. It just rips it apart, basically. Water is attracted to the particles, so it slowly takes it apart. It would not do that if water was not polar, okay? All right, I'm going to show you one more video. This one is called, Why Doesn't Oil and Water Mix? Let me rewind it and let me turn the volume up.
Our YouTube channel, and in the video today we're looking at why oil and water don't mix. There Made of different elements and with distinct structures, densities, and even dissimilar polarities, it's no wonder oil and water don't get along. They can be forced to cooperate, however, and there are several examples of this that are likely currently sitting in your pantry or refrigerator.
I don't know if you've ever seen this where you've mixed water and oil and they just kind of bubbles up and doesn't mix into the water. He's going to explain why.
But why don't oil and water normally mix? Water, H2O, is a stubby molecule with a slightly positive charge on the hydrogen H end and a slightly negative charge on the oxygen O end. The oxygen atom actually steals electrons from the hydrogen atoms. Called a polar molecule, the negative poles on each water molecule are attracted to the positive poles on other water molecules.
This is the negative side.
And as a result, they knit tightly together with hydrogen bonds. In fact, oil floats on water because it is less dense, with these super tight hydrogen bonds between water molecules holding them closer together than the bonds between the fatty acid molecules that primarily make up oil. As for oil, it's a non-polar chemical, since the atoms in the fatty acids in oil
that's what oil looks like, but really close up.
They usually have no charge, or at least
and it doesn't have the lines in between.
Molecule polar. Given their lack of positive or negative charge, they are not attracted to a polar molecule like water.
Okay, so he's saying that they're different because oil is not polarized. It doesn't have a positive or a negative side. And so the water molecules can't really be attracted to, there's no like positive to be for the negative to attract to or negative for the positives to attract to. It can't get to it.
Given that oil essentially repels the water, it is called hydrophobic or water-fearing, as opposed to hydrophilic or water-loving. As such, eventually all the lipophilic or fat-loving oil molecules will join together, floating on top of the water. However, although they seem determined to stay apart, it is possible to mix oil and water in a more or less stable solution, and there are several examples of this in your kitchen. One of the most common examples of where this occurs is in salad dressing. To get the two main...
By the way, I'm not going to be testing you on this information, this part of the information at least. So this is just extra, but it's interesting.
Ingredients: vinegar, essentially water with acetic acid, and oil to combine and stay that way for some amount of time. It involves two steps: breaking the oil into tiny droplets so it can be evenly dispersed throughout the mixture, and adding a mediator called an emulsifier. The end solution is then known as an emulsion. Different emulsifiers work in different ways. Some, like lecithin, found in egg yolks, have both a hydrophobic end that oil likes and a hydrophilic end that water likes. Thus, they are capable of bonding with oil and water.
So what he's saying is basically if you take oil, which is not attracted to water, and you take water, which is not attracted to oil, but if you put something in between them that's attracted to water on this side and oil on this side, then it kind of helps them stick together because it's being the ones they're attracted to, and that's called an emulsifier. The thing in the middle emulsifies. So instead of being a solution, it's called an emulsion, okay? Because it requires something else to help bond the water and the oil, and he's going to give a few examples of that.
So, as long as the oil droplets are sufficiently tiny and thoroughly dispersed, and enough emulsifier is used, the combination of oil and vinegar will remain as a relatively stable blend or emulsion. On the other hand, an emulsifier like tomato paste has protein molecules that more or less coat the oil droplets and prevent them from bonding together, keeping them relatively well dispersed in the water. While it gets there differently, when mixed, the end result is about the same. So when making a typical dressing, you first mix together the emulsifier or emulsifiers and the vinegar, and then slowly add a thin stream of oil while whisking or blending vigorously and constantly. Between the thin stream and determined whisking, the oil will be broken down into tiny drops and dispersed, and since the emulsifier is there to either coat the oil or bind it to the vinegar, it will remain suspended in the mixture for a good deal of time. So I really hope you found that video interesting.
All right, let me stop my screen sharing. Okay, so hopefully that helped make sense. Like I said, we talked about these terms. Okay, we talked about a solution. A solvent. A solution is when it's mixed together and creates one solid thing, not just pieces of stuff next to each other. Solvent is the one that does the dissolving, so water is a good solvent. Solute is the thing that gets dissolved. The example we used in the video was salt. Okay, that's an example of a solute. Polarization is when the atoms are one side of the atom, the molecule when there's a couple atoms combined. So one side of the molecule is positive and one side is negative, okay? And we talked about ionic bonding, which was a review, and an ion, which was a review as well. Okay, if you have questions, please let me know, and hopefully that made sense. Thank you.